All right, welcome to the first lesson of Unit 4B. So I'm actually split this one up into two different videos, focusing on the linear equation word problems. Students have a little bit of a challenge sometimes with this one. And I think breaking it up into two different lessons will help out a lot with the two. So I'm going to take a look at the first two. I'm going to look at word problems written in slope-intercept and standard form, and then I'm going to take a look at word problems on the second video that are using point-slope. So we're going to go ahead and get started on this, and our goal is by the end of the lesson you'll be able to read, interpret, and solve linear equation word problems. And there's lots of practice in your notes on this, and I've posted extra practice online with the answer key for you to check your work on that. Okay, so we'll start with slope-intercept form. So in slope-intercept form kind of requires two things. If you think about it, to do slope-intercept you have to have slope and intercept. So what do those translate to in this idea? So we need a given rate of change, which is our m, and then our rate of change is really going to be written, and this is really similar across, as some type of statement that connects multiplication to an item, like 2 for 1 or $3 per item. And these are really key statements, and this is actually a really key word right here. That one typically gives you the key to what slope is, and you need a starting point, which is b. So you need maybe a cost to set up an operation, or what you have to buy ahead of time. This one is a big business formula they would use. Okay, so what did I have to pay to get before I make any money? Okay, there's my investment. Now, how much do I charge per item so that I can figure out how long it will take me to make a profit? So, and this is our idea. So we're looking for a rate of change, some type of per statement, and some type of starting point, something I have to pay before I can do anything related to that per statement. So you and your friends plan to attend the county fair this weekend. The admissions fare for the fair is $5, and the cost per ride is 50 cents. If your parents give you $20, write and solve a linear equation to find out how many rides you can go on. So let's look for the starting point. So remember, this is what you pay before the per statement. Okay? And then the rate of change is this idea of how much it is per something else, some kind of rate of change, $2 per item. So this one is a lot of times easier to find. So it's a 50 cent per statement. So it's 50 cent per ride. How much do I have to pay before I ride anything? I've got to pay a $5 fee just to get into this county fair. So I'd write my equation and go, okay, y equals 50 cents times how many rides, x is rides, plus 5. So y is cost. X equals, let x equal rides. And then based on what you're given, you figure out what you're solving for. So now my next portion, I'm given $20. Okay, and that's the total I have to spend. So I'm going to plug that in going, okay, 20 equals 0.5x plus 5. You know what, I actually like fractions more than I like it than decimals, so I'm going to switch this to a fraction. You could leave it either way, it doesn't matter. So half a dollar, same idea here. So first thing I do is I subtract off and solve for x. I subtract off this, so I'm going to get 15 is equal to 1/2 of x. And then to get rid of a fraction, I multiply by its reciprocal. So this 30 is equal to x. So even with the idea, I can ride 30 rides, or 30 tickets worth of rides, to go ahead and do that. So same thing here, we're looking for this, and this is another key idea. So maybe you want to know how much you can sell your car for, or you want to know how much your car is worth. Your parents decide to buy a new 4Runner for $25,634. Yes, it's used. According to the dealer, the car will depreciate approximately $3,000 per year. Write and solve a linear equation that will find how many years until the car is only worth this amount. So really what we're looking at is, okay, where's my starting point? Since I've got to find m, I've got to find b, and I need to know what x and y stand for. So x, so if I think of my per statement, that's what I want to find. Okay, there it is. I've got that word per. So it's going to depreciate. That's the key to this one. So it's actually a negative $3,000 per year. Its starting point is $25,635. Okay. So if it's per year, so Y has to be year based on my basic form, and this one has to be worth or call. Okay. So now I've got this, and the reason I knew that the other one had to be cost is because I look right over here, or this one had to be year. If I know my slope is 3,000, and I know there's my unit for my x, because x has to be per year times year, and that's really what this multiplication. And then our starting point is that b. Okay, so let's plug what I have in. I know that y is equal to 3,000 times the amount of years plus how much I paid for the item. And I know, based on that, I know I want to know how long will it take to roughly equal that amount, $3,135. So again, I'd solve, I'd subtract off this 25,635. Okay, so 0, 0, okay, carry, so that gives me 5, 2, all right, so I'm really doing this is going to be my negative answer, so I'm really working kind of weird on this one. So really it's like 6 divided, subtract by 1, 5, 5 says 2, $22,500. Okay, so I know that's roughly the amount. And now I've got negative 300, and it's a negative number because I had to subtract it. 3,000. I know you're using your calculator, I just didn't have my calculator with me, so now I'm going to divide everything by negative 3,000. And I get roughly that 7.5 is equal to x. So in about 7.5 years, and y is years, so we're just going to say 7.5 years. It's going to cost only about $3,000. Something you paid $25,000 for is only going to be worth $3,000 in about 7.5 years. So that makes for a big difference. All right, last problem. That's the last problem in that section. So I really want to talk standard form now. What we know about this is this one, if you take a look, you actually have 2 per statements. Okay, you don't have the starting point. Okay, so this would be, say you need 2 things to buy. You need pencils and paper. So how much does it cost you to buy a pencil, and how much does it cost you for paper, and this is your total cost. So great, again, another formula you use heavily in business. Okay, I have 2 items I have to buy to pay my total cost, or I need this and this so that I can build this. How much is it going to cost me? All these pieces together to cost me to build, say, maybe a new iPhone. I need X number of pieces. This is how much it costs me per piece. There's my total cost of building the iPhone. Now how much am I going to charge so that I can bring a profit together? So you really need these 2 different objects or 2 different rates of change. And that's really the key to this problem. Slope-intercept gave you a 1 rate of change and a starting point. This gives you 2 rates of change. So as we read the problem, that's what we're looking for, those 2 rate of change. And that's the kicker to find this type of problem, what equation to use. So again, it was ax plus by equals c. So tickets to the school play are $4 in advance and $5 at the door. And you might have this, say for your football games, it's $3 for students, $5 for adults. Or playoff games, it's $10 in advance and $13 at the door. Okay, and then you have a total ticket sales for the evening productions was $404. If no tickets were sold in advance, write and solve a linear equation to solve the problem. So I've got these 2 per statements, $5 per ticket and $4 per ticket. So X and Y actually both happen to be, X we'll say is advance tickets, and Y is equal to our door tickets. And it looks like C is our total revenue. C is revenue. That's just simply how much money we make for the year. And now from here, I'm going to plug everything in. So I know that I've got 4x plus 5y is equal to 440. So at this rate, I still can't solve the problem. I need to know an x or y so I can solve it. So as we read this last statement, that tells us if no tickets were sold in advance, write and solve a number to find out how many were sold at the door. Well, so if I know this is my advance tickets, so it's 4 times 0 plus 5y is equal to 440. So I'm really at just 5y is equal to 440. Divide both sides by 5. So y is equal to, quick math, 88 tickets sold. And 88 door tickets specifically. Guess this group doesn't plan ahead. All right, so it really would make a difference if you did advanced tickets last year. It's not going to encourage them, or you need to lower your price for advanced tickets to get people to buy them in advance. All right, let's take a look at another problem. So Karen's piggy bank is all dimes and quarters. The total value in her piggy bank is $11.40. If Karen has 36 quarters, write and solve a linear equation to find out how many dimes she has. Now, a lot of kids can manipulate this and go, oh, well, I can turn this into a slope-intercept problem, and you're very much right. I'm actually going to show it to you both ways, as it doesn't really matter which way you do it. And I wouldn't penalize you either way as long as you get the right answer. That's one of the great things about math. So I'm going to start with standard form over here, ax plus by equals c. And I'll say, okay, she has dimes and quarters. So we'll say a equals dimes, or x equals dimes, y equals quarters. So I don't have numbers, but I do in the terms if you think of, okay, what's the value? Since that's what I'm looking for in C. C is value. So I get 0.1x plus 0.25y is equal to $11.40. Now once I get that, I need one of the values, and I have it. So 0.1x is equal to plus 0.25 times 36 is equal to $11.40. Well, okay, so you're going to just simplify what you can. Point x is equal to, or plus 9, making the same mistake repeatedly, equals $11.40. So you subtract 9. 1x is equal to $11.40. And you divide each thing by 0.1. Okay, and it's not, I'm sorry, I didn't finish this math correctly. Sorry, this is only $2.40. So I go, okay, each x is equal to 24 dimes. And then you could do the same thing with the slope-intercept. If you think, okay, I've got slope. So starting point, you'd have to go back and do a little bit of math, and you'd have to recognize, okay, 36 quarters is equal to $9. So B is 9. X is still your dimes. And you have slope because you have per dime. So you have $11.40 is equal to 0.1x plus 9. And that's really what we got right here. It's the same equation, just getting to it, deriving it two different ways. It doesn't matter which one you use. You honestly can use pretty much any formula any way you want to get these problems right. Okay, and then the last one, we're going to jump in, take a break here, and then we'll talk about point slope problems in the next video.